it wants the opportunity to watch it again.
All right. Hello, everyone, and thank you for joining our webinar today on navigating and installing an EV charging system for multi-unit residential buildings. My name is Sharif. I'll be your presenter today, along with wmann. So our aim today is to unfold the process of selecting a working solution for an EV charging system for multi-unit residential buildings. It can be complex and overwhelming, and we wanted to share our experience and explain the solution process so that we can help our customers, that we use to help our customers. So on our agenda today, we want to look at the EV sales trend that's driving the EV solutions and systems market. And then we'll talk briefly about the main group itself. And we will then look at some of the chargers and compare them. And then we'll look at the charging system solutions. Finally, we'll talk about funding, how our process looks like, how we work with our clients, and then we'll take questions at the end. So as far as EV sales, as of Q3 2021, over 1 in 20 new vehicle registrations are either battery EV or plug-in hybrid electric vehicle. And with this demand, EV charging stations will increase proportionately as more and more electric vehicles get on the road. So this is driven by also the government of Canada requiring that 100% of cars and passenger truck sales to be zero emissions by 2035. And to look at what's happening today, Statistics Canada has reported that the proportion of new vehicle registrations that are electric vehicles has dramatically increased compared to the same quarter last year. In terms of numbers, 25.7% increase in battery EV registrations in Q3 of 2021, and 72.8% increase in plug-in hybrid EV registrations. Ontario is in the 3rd place in Canada. Looking at a graph here demonstrating what happened in Q3, 23,900 cars, almost 24,000 cars were either battery EV or plug-in hybrids. And that's almost 5.5% of all cars registered in Canada. And with the mandate to be 100% electric by 2035 in terms of sales, we expect this to be more and more exponential in growth. So what do our clients ask us? That we aim today to answer some of these questions. We get questions like, how many chargers should be installed in my building? How many chargers can I install in the building? How many my building can handle? How long should a car be connected to fully charge? How do I bill my tenants for their charging system, for the amount of power they consume? Is there funding, government funding that can help me? So before we start answering these questions, we'll talk briefly about our group and expertise. So the main group of companies was founded in 1988. Our services include a consulting group, and this group is focused on sustainable strategies, and it's led by our professional engineers. We also have a project management group, and we act as your consultant for traditional tendered projects, and we offer project management services for construction projects. Our construction group is focused on design and build with a mandate that ensures energy conservation and construction services to our clients are at the best possible value. We also have an automation control and monitoring group, and it's focused on providing automated solutions, building solutions for our clients using the best technology for the application. And the monitoring group has a task of delivering emergency dispatch. So this group watches the buildings from our office, and they dispatch emergency response for energy-based events in our customers' buildings. Our expertise include EV charging. Our electric vehicle charging group focuses on solution-based approach that accounts for unique client and building needs for today's and tomorrow's demand in their buildings. Our electrical engineering and services group specializes in electrical works, including engineering and implementation. Our firm has hundreds of installed electrical projects and provides power solutions that follow traditional engineering practices. We also have our energy management group. It focuses when we're working with customers on the energy audit process, and it's the first step in identifying energy savings and energy cost reduction opportunities, reducing greenhouse gas emissions, improving comfort in the buildings, health and safety of the occupants. We also have an alternative energy solution group. We have extensive experience with alternative energy, including solar PV and CHP. On-site generation increases energy reliability and reduces reliance on electrical utility. And because of our experience in HVAC, we are also very well versed in indoor air quality. So it's a growing area of focus for building operators and businesses. And we achieve it through having safe air circulation in their buildings by preventing or reducing the circulation of harmful particles in the air. So I'll hand over to Wes here to start talking about some of the technical aspects, the chargers and the charging solutions.
All right, perfect. Thanks, Sharif. Hi, everyone. I'm Wesley. Yeah, so, there's so many chargers and suppliers in the market, and our goal as MAN Engineering and MAN Energy Solutions is to provide our clients with guidance in this process. We're a neutral party. We don't necessarily associate with any supplier or charger directly. And our goal is to help find solutions that fit the application that our clients are looking for. And like I said, there's tons of different possible configurations of systems that can be suited for any particular application. So we'll start off just by a quick overview of the different charging speeds that are available. And then you may have heard these before. So there's level 1, level 2, and level 3 chargers. Level 1, it's pretty slow, 120 volts AC, 15 amps. So this is like pretty much what you would plug into a regular wall plug. Typically, we don't really see these installed in multi-residential buildings. It's more of a backup that you would carry around in your car kind of thing. Level 2 chargers are what are typically installed in multi-residential buildings or in homes. Like I have a Tesla Model 3, and I have a level 2 charger installed in my garage, and it's a 40 amp service, which is pretty much kind of the sweet spot for most people, because that'll give you an 8-hour charge time from empty to full. But level 2 chargers can range between 15 amps and about 80 amps. So that gives quite a range of charging speeds. And then level 3 chargers are your DC fast chargers. So this is what you would see at like a supercharger, Tesla supercharger station. It's not typically seen installed very frequently in multi-residential buildings, and the reason why is just because the demand for the electricity, the load, is just really high. Like we're talking about 120 kilowatts plus, so most buildings don't have the capacity to be able to handle those. So we would typically recommend level 2 chargers for most applications. Next slide, please, Sharif. Yes. Okay, and then I'll just give a quick overview of the different types of charging systems and networking options. So our non-network system is kind of like what you would see in a single family home installation. So it's a dedicated circuit breaker. So if it's a 40 amp service, you have a 40 amp breaker, which is dedicated just for that charger. And it's standalone. So it doesn't communicate with any of the other chargers for load management purposes. It doesn't have access to the internet, so you can't collect usage data or monitor for problems or balance loads using a power management system, or you can't charge users a fee for plugging them in, for example. And because it has a dedicated feed, it's not really scalable. It doesn't have a power management system, whereas the other options that I'm going to talk about do. So OCPP is a network system. So OCPP is an open source communication standard for EV charging stations. So they're typically like a smart charger that would be connected through OCPP to a cloud server. And this is generally handled by a third party, and they can provide payment solutions directly to the users. And this can be like a pay-as-you-go type system. And then we're going to talk about like a central metered and power management panel. So this would typically use, it wouldn't be smart chargers. You know, you'd have your standard dummy chargers, and they would all be hardwired to a central controller. So this would be like local, located in the parking garage or in the building somewhere. And this would actually be connected to the internet, and you could handle your payments through that central controller. And that central controller can also manage the power distribution to the chargers themselves to provide load management. And Sharif, next one, please. Okay, so this is just a kind of a network overview for like an OCPP system. So on the bottom left there, you can see that the charger themselves, which would be charging the cars, and then the OCPP system would connect through the internet to like a cloud server, and then the cloud server can handle your like integration systems. Like you can have a third-party payment solution, or you can have an app that you can manage your or monitor your consumption of your charger in real time. So these are like the solutions that are available. And then the only difference with like the central metered solution that I was talking about is that instead of the chargers themselves connecting directly through the internet, through Wi-Fi, whatever, to these central, like the cloud server, it would be a physical local panel that would be installed in the building. And that panel would be connected to the internet, and that could handle your payment solutions. Okay, just going to do a quick pros and cons for the different types of systems. So like your non-network systems, so this is kind of like what you would typically see in a single family home. Obviously, it's the lowest cost to implement, but like I said, it's not scalable. The reason being is it's like you have a 40 amp dedicated breaker for that charger, and whether or not it's being used, it doesn't matter. That 40 amps is still reserved, just because if you have 200 amps available in the building, and you have 40 amps dedicated for each charger, even if they're not being used, the building has there's no load management. So we don't know if those chargers are being used. They have to be reserved, that 40 amps, just in case they're all being used at once. You don't want your building to trip the main breaker. So it's not really scalable. You're going to find if you're going this route with a non-network system, you're going to run out of capacity very quickly. So for larger systems, in multi-residential buildings, that's why we're typically going with some type of network system that has power management. So like the OCPP system, it's typically like a pay-as-you-go type of solution. That's generally the application that we would recommend for this. So this would be applicable for like a visitor parking or some type of public parking where you have multiple users that are going to be using the chargers. It's not necessarily one tenant. So that's kind of the best application for these types of systems. And then when we're talking about a central metered panel, that's when you have like one dedicated tenant. So you'd have the tenant would reserve a charger for their parking spot. And so you only have one user. So then these individual chargers would be connected back to our main controller panel. And then that control panel can handle the dynamic load management, and you can bill your tenants monthly based on their consumption. Now you could do this you could directly bill them based on the metering information, or you could have a third party which would handle all the billing for you. And then you would just the third party would just take the payments and then take their fee, and then at the end of the month they would pay back the condo corporation. Yeah, so I talked about load management systems. So the way that these systems would work is, and like this is what I was talking about, where when you get into larger systems, you really need a load management system to ensure that you're not going to be exceeding the capacity of the building. So there's two components. So first, like the load management system would be, can monitor the real-time energy consumption of the building. So, when everyone's coming home from work at 6 o'clock and plugging in, and they're also going to be, using all their in-suite power, you're going to find that the capacity of the capacity of the building is going to be much lower during these peak times because just of the usage of the building. So, there might be less power available for the EV chargers during these times, but in the middle of the night when the building's not using very much power, that's when there might be a lot of spare capacity for the EV chargers. The EV chargers are going to be the lowest priority for the building, obviously, because you need to maintain all the other systems in the building. So this system is just going to make sure that we're never exceeding the amount of available power that the building has. And like this limit, because a lot of building owners are worried that they're going to have to upgrade their service for their building. And with these types of power management systems, we can fit a lot of chargers in a building without having to upgrade the service, just by making sure we manage the power consumption. And then, after we manage, we monitor the load, the capacity that the building has available, then we would tell the chargers, okay, you only have 200 amps right now. And then the system would manage how much energy the chargers are using. There's two methods for this, like load shedding, which would be, it's like a first come, first serve system. So the first person to plug in, they get to charge first. And the last person that plugs in, if there's not enough available power, then they won't be able to charge until the first person is finished. So that's a load shedding system. We're moving a lot more towards a load sharing system now, which is everyone is able to charge at once, but it just reduces the speed of the charging for each charger equally. So, instead of being able to charge at 100% power, they're going to all derate to like 50%. So everyone gets to charge, but it's just a slower charging speed. So that's kind of what we're seeing more demand for, because it's a little bit of a better system.
All right, so thanks, Wes. So I'm going to talk a little bit about funding. So currently there's one program, Zero Emission Vehicle Infrastructure Program, and it's on first come, first served basis. So we're hoping that will open again. It's a 5-year program. We're hoping it will open again in the spring, and that's what we expect. This program has a total funding of $280 million, and it will end in 2024. It might be expanded with the demand that we see today, and it's done through distribution organizations, and it can be also done through individual applications. So how the funding works for level 2 chargers that are in 3.3 to 19.2 kilowatt range, the funding is for up to 50% of the total project cost and up to $5,000 per single connector or charger. For fast chargers that are in the range of 20 kilowatt to 49 kilowatt, it's also 50%. Funding is 50% of the total project, and a maximum of $15,000 per charger. So the rest of the fast chargers, they're not typical in a multi-unit residential building like an apartment or a condo building, but they could be used if there is if it's a mixed-use building, or if there's a visitor parking, for example, that the owner would like to use and can also generate revenue from it. And the rest are also structured the same way. 50% for the total project, and $50,000 per charger for 50 to 99 kilowatt, and $75,000 for 100 kilowatt and above. And the program also fuels any zero emission vehicle, including hydrogen powered fuel stations. So the way we approach these projects, we look at it from what is best for the building. So we look at all the solutions in the market and we select what works best for this unique building and the client. So we start with a feasibility study where we look at things like what Wes was talking about. We look at first the distribution system of the building, and we look at the spare capacity that's available. And we typically go visit the site at least once. We look at the single line diagram, and then we select the best option based on the available power, select the system that will provide appropriate power management for that particular building and demand, and spare capacity. And we do, in the feasibility study, we provide pricing. We look at for the different options that we believe would work best for that building. Once that's done, we offer a stage 2 as well, where we can be consultants for the rest of the project, where we would tender out the installation process for the installation contractors and procuring the equipment, and then project manage the project. The other option is engineering, procurement, construction, where it's more like a turnkey project where we take ownership of the entire construction process for a fixed price. And finally, we apply for funding on behalf of the client, facilitate the funding process. Okay, so we'll start taking questions now. All right, so you can put your questions, type them in the Q&A, or if our mics are open, we can take them live as well. Okay, so we have a question from Andrew. What kind of systems are you seeing installed in multi-unit residential buildings at the moment? And how many stations per building are common? So there is no single answer to this. The systems can vary. It really depends. What we look for is a system that has a low operating cost in the long term, and that's typically is the best option or the better option for condo building, for example. In an apartment building, it might be a mix of smart chargers plus smart chargers that can be easily exchanged between different tenants, or a communal charger where it would be different from a charger that does not have the capability of doing point of service charging. How many stations? We see a lot of people starting with about 20, and then the expand. So when we're looking at solutions, we consider scalability as part of our analysis and selection. Okay, Wes, you want to take the next question on payment systems for the network systems?
Sure. Yeah, so Liam says, can you elaborate on the payment system for the network systems that are preferable for the individual tenants, central panel / controller? Is this set up from the manufacturer of the system, or can the usage easily be monitored by building staff and then determine how much is owed that month? Yeah, very good question. So yeah, when we're talking about individual tenants, the solution we generally recommend is the central panel controller, what I was mentioning in my presentation. So this it can give the control directly to the building owners or property management, because really all it's doing, this central controller, is it's hardwired to each of the individual chargers, and it's metering them. So this metering data is available to the building, so they can bill directly to the tenants. There's also, since it is connected to the internet, there are third-party solutions which can manage this process for the building and do the monthly billing to the tenants. But it's really your choice. Like you can handle it. The building can handle it themselves, or they can pass it off to a third party. Hopefully that answers the question. Yeah, I mean, like what I was talking about. So that's more for when you have like an individual tenants that's looking for their own charger. When we're talking about multiple tenants sharing a charger, or like some kind of like in a visitor parking situation, that's when you potentially want to go with an OCPP system where you have a smart charger, which is pay as you go, and that's just communicating directly with like a cloud client software, which will handle all the billing.
So if you have questions later, please send them to us by email, and we'll respond right away.
Hey, Sharif, Andrew has another question here. You want to take that one?
Yeah. Okay, how long does the process take from first contact to install typically? So it depends on the size of the system, but the initial study will take anywhere from 4 to 6 weeks. And then there's the next step would be the tendering process. If we go the tendering solution, it can take another couple of weeks as well, for another 3-4 weeks. And then the installation is typically, depends how smooth the whole permits, ESA permits and access process would go. It could take another week or two, provided that equipment, of course, can be procured without delays. So I would say it's a 3 to 4 months process in total.
Sharif, you want to take that question?
Right, for the from Liam, for the scalable systems, many property managers are looking to start small and add on over time. Are the current offerings fairly easy to scale from the same central hub, central panel system or network system? Or will they be expected to conduct upgrades as they look to add more chargers? Essentially, what are you seeing for longevity for the current product offerings? So okay, so let's talk about the central panel system. So if the central panel system initially can operate standalone with available power that's supplied to it, in terms of scalability, additional panels can be added, and then they will be connected together and connected to a central management panel that will coordinate the power supply to the different panels. So it's a modular solution. It's not complicated to expand. The good thing about it is that all the tenants, they share the initial cost in a condo situation. For an apartment building situation, it really varies how the owner want to handle this. If they think that they want to provide a certain number initially to accommodate current demand and then scale it up as the demand increases, or do you want to provide or do you want to add more or have a larger number of chargers initially to maybe increase the property value or attract more tenants? So it really depends on what the owner of the building would prefer. But in terms of scalability, with either solutions, it's fairly simple. It will, because the network solution, whether it's OCPP or panel, they both require some construction, of course, to run the wiring and connect to a transformer and a panel, electrical panel, and both of them would pretty much require the same amount of effort to expand the system and provide additional power to more parking stalls. They're both expandable. They're both scalable. Like I said, like the operating cost for the OCPP or Wi-Fi network requires it's more expensive to run compared to the panel system, but the panel system is more expensive to install initially. So there's a little bit of trade-off. Both systems work. The smart charger system may be more convenient for changing tenants quickly, where the tenants do not bring their own chargers, and you need to have the tenants be able to pay on the per use. Or if the panel system is used, then you get charged monthly. So, but in terms of scalability, they're both scalable, and they don't require massive investment.
Yeah, I just want to jump in here and say, typically what we would recommend to start off with is doing a survey of your building. because like you say you want to start small, but you never know. You might have a lot of interest in the building, especially now. A lot of people are considering switching over to EVs, but they know they don't have a charger available, so that's maybe holding them back. So what we generally recommend is to do a survey of the building and to gauge the interest, and then the initial capital cost of installing the first panel can be shared among the people that are interested in getting a charger.
All right, so I see a question from Andrew Young. Do you work with EV charging manufacturers or suppliers directly? Do you have a preference, or are you open to new systems on the market to have more options and make recommendations based on the client's requirements and wants? So yeah, good question. So we approach all projects from a neutral standpoint. We pick the system that works better for the client based on their objectives and for the building itself based on the available power. So we look at all options.
Yeah, we're constantly meeting with suppliers in the market, and like every week we meet with the supplier to see what their new products offerings are and to gauge what type of different solutions there are that would work for our clients. So we're very knowledgeable in the marketplace of exactly what's available and how we fit the solutions that are available to the needs of our clients. So yeah, we're entirely product agnostic. Okay, I think we're getting cut short for time here. So any other questions that anyone has, feel free to send us an email and we'll be sure to respond. And thank you everyone for coming and listening to us. Sharif, you have anything else to add, or?
No, I just want to remind everybody that if you have any more questions, you can email them to us and we'll send you back the response right away.
Yeah.
Thank you so much for attending. I hope you found it informative.
Yeah. Thank you very much, everyone.
Thank you.